Hi, my name is Chris Barton, and this is my final project for computational advertising. So as mentioned, my name is Chris Barton. I'm a second year PA student. I have about 5 years of experience in data engineering, 9 years of experience in digital marketing, and about 3 years of experience in machine learning and data analytics. For this project, it is decided to make a budget allocation system for page search. I felt like that kind of married well with my background in both digital marketing and data engineering and machine learning. So essentially, the goal of the program is to, given a number of seed keywords and an incoming stream of search queries and a fixed daily budget, the program's goal is to find the optimal budget across all keywords. Essentially, this boils down to a multi-armed bandit problem with a few different tweaks. Um, and the ultimate goal is to, maximize the money and find the most optimal budget allocation in the least amount of time. So here again is a kind of a little bit deeper explanation of the program intent. So here we see the structure that I kind of have mapped out in my mind of how this program would work. So you create the top campaigns, so campaign 1 and campaign 2 here as broad set keyword matches, and then as the program learns more about the underlying distribution of keywords and values, it can then find these lower values and then create sometimes create more specific campaigns. Say if one keyword is extremely valuable and happens to has a lot of impressions, it might want to create a campaign specifically to target that keyword. So then once it starts creating these different campaigns, it can then just take a greedy optimization approach. So for the implementation, I use publicly available search query data provided by AOL. It's kind of funny since in one of the papers last week, the paper actually mentioned this data and how there's people were able to actually tie this anonymized data back to real people. I used PurePython for the project and in an object-oriented fashion. If you were to ever maybe implement this in real life, for a production environment, you might want to have a data warehouse and BigQuery to store all your AdWords data. You could use Google App Engine and their analytics and AdWords API to actually kind of implement this in real life. So I first wrote all the code, and I just started off before the campaigns can kind of create their own campaigns. I just tested it off for 6 basic campaigns. So I tried 4 different strategies: UCB, greedy, and not epsilon greedy, just greedy. A quote unquote God mode, which is the program is able to know what data is going to happen in each period, and then a completely random mode. So for evaluation, I just looked at the total reward for each of these. And below you can see the total reward for each of these strategy over about 45 periods. And about each period has about 10,000 keywords in it. So as we can see, God mode performs the best, followed by either UCB or greedy, and then random. Also, this was just taken on one pass. So I think if you really wanted a really good idea of how these different strategies pay off, you'd want to run this experiment hundreds of times and then kind of average the result to see the strategy. Since there is randomness in each of the simulations, they won't produce the exact same result, since there's things like click-through rate, which is a distribution, and also values of distribution and these other things. So you're never going to get the same exact results when running this program. So then on this next slide here, we can see the implementation for when I also programmed in the logic for the program to be able to create sub campaigns. So here I had 6 initial campaigns, and then campaign 3 and campaign 5 eventually created campaign 7 and 8. And then again, looking at kind of the how much improvement this offered, it didn't actually offer much improvement. And I think that's because when I looked at a little closer, campaign 7 and campaign 8, those keywords didn't really have a lot of impressions during every period. So It just, didn't offer a ton of value. But like in a different situation, I think it would still offer a lot of value. So if you have maybe like a keyword or two that, pretty much make up all of the search volume, it would be perfectly justifiable to create a separate campaign specifically for that campaign or for that keyword. Next up, we have key findings. So I think one of my major key findings here was things get complex quick. I feel like I spent a lot of time programming in this project, and things like even matching the keywords. Like, so a search query comes in, then you have to like match it to all the campaigns. Like, that takes like a whole set of logic right there, and then there's just all these things that can add up quickly. So for example, for the matching, I originally did it in kind of an inefficient way, so my program was taking forever to run. So I had to go back there and like kind of design that. And in real life, the search engines matching search queries to actual results is like a whole subfield within itself. So trying to kind of make a simulation where you have like all these little things and you kind of understand how they like add up, and just things get pretty complicated quickly. Also, another thing to mention along that line is since I was kind of like programming this pretty robustly, I feel like there would be times when I really start to think. I really thought about the program, spent a lot of time on that, and then you maybe are trying to like, once I see the initial results, and then I start in the mindset of how do I make these strategies better. Like just starting to think more about like the model and algorithm design. So then like once I maybe have a different idea for tweaking the algorithm, going back and re-implementing that code can be, a big deal. So also finding, I guess, the right balance between programming and kind of thinking about how to like maybe optimize the model is kind of a challenge. And maybe there's a better way to do it than programming first and then kind of looking at the results and thinking about a tweak. Maybe there's just a different strategy that, kind of makes the work process and like the iteration phase, I guess, of designing an algorithm more appropriate for this case. Another thing is I mentioned that there is a lot of randomness within this within the simulation, such as click-through rate, some other things. So I think like I'm looking at the results and I was surprised that UCB wasn't performing better than just a pure greedy strategy, and it just had me starting to think a lot more about like how randomness plays into each of these strategies. So like there's click-through rate, that's random. The underlying, value, some of the values are random. Most of them I actually hard coded in there, so they're not random. But also like the underlying impression volume for each of these keywords, I wonder how much that played a role. And maybe using the real AOL data set wasn't the right way to go. Maybe I should have actually just kind of created, kind of a stream of incoming search queries that have their own, distribution. That way I can kind of play with the knobs a little bit more and figure out what strategy might make sense in what, when the environment, like let's say when there's a lot of keywords with high impression and a high value, then maybe a certain strategy makes more sense than the other, than a different thing. But I kind of had the search queries income stream kind of fixed, so I wasn't able to experiment there. So I think there's a lot of work I could do around just figuring out how randomness plays into the various strategies, and seeing how that impacts maybe some design choices within the model. Another thing would be real world considerations. So in this one, I was able to witness value the second, the bid came through. If it had value, it had value. If it didn't, it didn't. But in real life, that will, that could take several weeks, maybe even a month in some cases. So that could be a major issue. So how you would want to incorporate that would be like a major, I think, challenge in implementing something like this in the real world. And I think something you could do there is just have a proxy for session value by looking at the activity. And I think that probably correlates pretty well with, the eventualness of a conversion or not. So that is pretty much it. Thanks for listening.